Welcome to the NRC's 37th Regulatory Information Conference technical session titled Quality Assurance, the Foundation for a Safe Operation of Nuclear Power Plants. My name is Carrie Cavanaugh, and I'm the Chief of the Quality Assurance Vendor Inspection Branch and the Division of Reactor Oversight in the Office of Nuclear Reactor Regulation. It's an honor to welcome you all to this important session. Before we get started, I'd like to go over a few housekeeping matters. If you need the Wi-Fi, the password is RIC, all capitalized, 2025. Please remember to silence your electronic devices, including your smartwatches. All sessions are being video recorded. The Q&A portion of this session will be through electronic means for both the virtual and in-person attendees. For those of you in the room, you may have scanned the QR code for this session from the displays in the foyer, but if not, please take a moment and scan the QR code displayed on the screen to your device so you can participate in the Q&A session of this meeting. The QR code will drop you to a page specific to this session, and you'll have a tab for the QA where you'll input your question. For those of you joining virtually, once you have logged on, joined this session, there's a tab for Q&A box where you will input your question. Questions from both the online participants and those using the QR code will be added to the same queue, and we will try to get through as many questions as we can in the hour and a half that we have planned. As we close the session, you will be invited to scan the feedback QR code and share any thoughts or insights you may have pertaining to this session or to the conference in general. The purpose of this session is to explore one of the most fundamental pillars of our industry, ensuring the highest standards of quality and safety. This session will provide us with a unique opportunity to exchange knowledge and to discuss current challenges the industry is facing in the implementation of quality assurance. In this session, we will hear from experts from the NRC, the Canadian Nuclear Safety Commission, and the chair of NQA-1 Standards Committee. We will focus our attention on frameworks, standards, and approaches that ensure nuclear energy remains a safe and reliable resource for all of us. At the heart of this framework are the criteria of Appendix B to 10 CFR Part 50, which outlines the quality assurance requirements for the design, construction, and operation of nuclear power plants, including small modular reactors and advanced reactors. As most of you know, the NQA-1 standard is an acceptable method to meet the requirements of Appendix B to 10 CFR Part 50. However, it is not the only method to meet the applicable regulatory requirements. Excuse me. Both Appendix B to 10 CFR Part 50 and NQA-1 offer a graded approach to quality assurance. This approach recognizes that not all system structures and components are of equal significance to safety. We will focus our discussion on various acceptable approaches used in the United States and Canada to classify structures, systems, and components, differentiating between those that are safety-related and non-safety-related, and the quality assurance requirements to be applied to ensure performance reliability. Our first presenter is Mr. Brandon Johnston. Brandon is the Director of Management System Division for the Canadian Nuclear Safety Commission. He leads a team of specialists who assess management system compliance for licensed nuclear facilities in Canada. Brandon has worked in quality assurance and management systems for 25 years in the nuclear, medical, and pharmaceutical industries. Brandon is a member of the Canadian Standards Association Technical Committee for Management Systems and holds an American Society for Quality ASQ designation of Certified Quality Auditor. Brandon, the floor is yours.
Thanks. All right, good morning, everyone. Before I start, I would like to thank Carrie and everyone from the Quality Assurance and Vendor Inspection Branch for the opportunity to join you today. What I have learned this week from every other first speaker in the morning is that having this time slot is not a coveted position at RIC. So I'm going to do what I always do and start with a little joke. A neutron walks into a bar and says, "How much for a drink?" The bartender replies, "For you, no charge." For those of you that may not know, work is underway in Canada to build our first small modular reactor, BWRX 300 unit, proposed to be built at the Darlington site adjacent to 4 CANDU reactors currently in operation. At the CNSC, significant work has been ongoing for some time to be ready for our role in licensing and regulating new reactor technology in Canada. Today, this presentation will cover the CNSC's regulatory framework, the licensing basis for management systems and quality, regulatory requirements for design and safety significance for structures, systems, and components, SSCs. I will also talk a bit about QA for the supply of items and services and ongoing work related to harmonizing and benchmarking of regulatory requirements. Oh, it works. Fantastic. The regulatory framework at the CNSC starts with Nuclear Safety and Control Act, passed by Parliament, which, among other things, established the CNSC as the regulator. Regulations are written and issued under that act, such as the Class 1 regulations used for nuclear power plants. Regulatory requirements are also contained in license documents issued to nuclear facilities. Much like the US NRC covered in the session yesterday on codes and standards, the CNSC also looks to leverage consensus codes and standards to streamline our framework, including standards from the CSA, ASME, ICRP, and IEEE. There are more. CNSC staff participate in technical committees for a number of these standards. This example cascades through the levels of the framework from the previous slide as it relates to regulatory requirements for management system and supply chain. During application for a Class 1 facility license, the applicant is permitted to choose an alternate approach and not use the CSA N286 standard that's listed here, but it must be justified and demonstrated to be at least as effective and robust. In a similar way, the management system standard CSA N286 does not dictate that supply chain management programs must use CSA N299 for supply of items, QA and supply of items. However, in the experience of the CNSC, supply chain management programs that set N299 as the standard for suppliers has been demonstrated to meet regulatory requirements. This slide points out some important information that provides regulatory context around quality for manufacturing and points out some differences between US and Canadian regulatory requirements. The CNSC does not issue manufacturing licenses. This is part of the license to construct or the license to operate. Fuel fabrication facilities are licensed, but this relates to their handling of nuclear materials. The license holder's programs ensure the structures, systems, and components meet the appropriate quality level as part of the procurement process. I'm a big fan of flowcharts and Microsoft Visio, so I had to find a way to fit one of these in. Here we're seeing the flow of the design process feeding into QA requirements and a licensed facilities procurement program. There are regulatory documents issued by the CNSC providing requirements and guidance for design and safety analysis. It is important to point out that the licensee's management system is the overarching big green box to control all of these processes, and requirements are found in the CSA N286-12 standard. Each license holder determines if contractors will be used for certain life cycle activities, but they still remain accountable for the outputs. If a contractor is used, informed customer principles are important so that a licensed facility has the necessary competence to know what to do once the contractor is no longer part of the project. The US NRC and the CNSC have recently issued a joint report that talks about classification of SSCs. It says that we largely agree, but there are some minor differences. To me, this figure from the joint report does a great job of illustrating the different approaches to safety significance. It shows the CNSC approach compared to the approach in the NRC licensing modernization project and the traditional NRC approach. The report indicates, and I quote, the CNSC approach may result in somewhat larger scope of SSCs subject to engineering design rules due to consideration of deterministic analyses and more conservative performance targets. However, there will be flexibility afforded to applicants' vendors due to the CNSC's risk-informed approach. I don't want to spend too much time on this slide. It talks about CSA N299. It's an industry-developed standard that, as I already indicated, can be used by licensed facilities to help them meet management system requirements. The series of documents was originally called Z299 when it was developed in the 70s. It's an excellent example of a graded approach for quality requirements for supply of items as each category builds upon the last based on complexity. The standard includes guidance for a selection process to determine the right quality level to be used for an item that uses two methods. There's an analytical method with questions related to management controls needed for the desired QA level, and a factor rating method with numerical ratings on specific criteria in an annex table. The user runs through an item through both methods, and the standard guides you to choose the higher of the two results. Many activities undertaken by the CNSC aim to have a positive impact on efforts for harmonization. Here are four categories for these activities, and then the one part of the presentation that moves is that we highlight benchmarking. It's the one I want to look at today. We undertake benchmarking efforts and to continue to reinforce that the CNSC and NRC approaches are similar but not quite the same. There was no way to present this information with an infographic, so I'm sorry about that. Two benchmarking activities important to quality that have been undertaken by my group. Staff have looked at how different international regulators handle supply management. Spoiler alert, we'll see that in the next slide. And staff have also done some comparison of supply chain standards, quality assurance standards. The comparisons with the asterisks are related to increasing attempts, some successful, to use the multiple standards in nuclear facilities in Canada. N299.1 and NQA1, when compared, we identified very few gaps between the two, although it's important to point out that our method was just a direct mapping of requirements. This project was conducted in part by Dan Papaz of my group and presented to the NEA's Working Group on Supply Chain Management originally. We learned that regulators take different approaches to inspections of suppliers based on a number of different factors, including resource availability. This slide is here to demonstrate that while the CNSC does not directly inspect manufacturers as a part of the supply chain for a licensed nuclear facility, there are provisions in our regulatory framework that allow CNSC staff access. We are looking at what compliance activities may be undertaken by staff as part of the new SMR project. Activities will be driven in a risk-based manner, considering that the new SMR is a first of a kind for us. These are topics that we like to think about when we ponder harmonization activities. If we're looking at the risk category, there's a consideration for the minor differences we discussed earlier. At the same time, each national culture has a different tolerance for risk that we try to consider. For language, some terms have industry definition that is different than how the words are defined in the English language. Management review versus management assessment. These are very different activities as defined by the industry versus definition from a dictionary. For oversight, as the world becomes a smaller place, there are questions about how and by whom that must be defined and answered, both at the regulatory level and in industry, where different organizations are responsible for different life cycle activities. In discussing responsibility, complex partnerships that we're starting to see, these models need to have clearly documented responsibilities and accountabilities. The operator is the licensee, but decision-making processes may involve numerous stakeholders with different levels of authority. This information needs to be well understood by the regulator. In closing, the CNSC is ready to execute its mandate for new SMR projects coming to Canada. QA is not difficult, but it does require attention to detail. Efforts continue to forward harmonization and cooperation. Thank you for your attention today.
Thank you, Brandon. Our second presenter is Mr. Yamir Diaz-Castillo. Yamir is a reactor operations engineer in the NRC's Quality Assurance and Vendor Inspection Branch in the Office of NRR and has been with the NRC for 24 years. Yamir is the NRC's representative in several ASME Section 3 Code and Conformity Assessment Committees and is currently a lead, a lead inspector in Quality Assurance in the Vendor Inspection Branch. Yamir also serves as the NRC lead representative for the Nuclear Procurement Issues Corporation. Yamir has a Bachelor's of Science in Chemical Engineering from the University of Puerto Rico in Mayagüez, Puerto Rico. Yamir, the floor is yours.
Thank you, Carrie. And good morning, everybody. I know this is the presentation. This presentation is the real reason why you all came to the RIC. So I appreciate that. Today I'm going to be talking to you about the role that the quality assurance requirements from Appendix B to 10 CFR Part 50 play in the NRC's licensing process, and also several pathways available for meeting the requirements from Appendix B to 10 CFR Part 50. Does anybody know or have heard of Dr. Joseph Duran? Anybody? Just you? Okay, all right. Well, at least one person. So he's considered to be by many the father of many of the quality management techniques that are still being used in the industry today. He actually lived to be 103 years old. He was an adjunct professor at NYU in the Industrial Engineering Department, teaching courses on quality. And he was responsible for developing the Duran Trilogy, which consists of 3 processes that together make up the overall quality management journey. And these processes are quality planning, or in other words, quality by design, quality control and quality assurance, and quality improvement. So what is my point in all of this? My point is that quality management and quality assurance is not new. It's been around for a while, and it should not be a challenge to implement. QA, or quality assurance, is a process, and the focus of my presentation is going to be and reinforce that quality starts at the initial design. It is the designers of the nuclear power reactors that are responsible for determining the safety classification of the structural systems and components, or SSCs, for their facilities, not the regulators. Let me repeat that again. It is the designers, not the regulators, who determine the safety classification of the SSCs for their facilities. And then once those SSCs are classified, then the appropriate quality management measures and QA are applied. QA, as we all know, is a graded approach. Adequately implementing nuclear QA does not lead and should not lead to significant cost increases and potential schedules delays in the construction schedule. On the contrary, not adequately implementing nuclear QA may result in significant cost increases and potential delays on the schedule. So the licensing process starts with an application for a construction permit, a design certification, combined license, design approval, or a manufacturing license, and must include the principal design criteria for a proposed facility. Excuse me. The general design criteria, or GDC, are an important part of the NRC's regulatory framework, and they establish the minimum requirements for the principal design criteria for light water reactors. GDC 1, as shown on the slide here, establishes the requirements that SSCs important to safety shall be designed, fabricated, erected, and tested to quality standards commensurate with the importance of the safety functions to be performed, must establish a QA program, and must maintain appropriate records. That's fine, Yamir, but what about for non-light water reactors? Well, I'm glad that you all asked. The regulatory requirements of 10 CFR 5034 and Appendix A to 10 CFR Part 50 recognize the difference in the requirements that may need to be adapted for non-light water reactors designs. The GDC in Appendix A, they're not regulatory requirements for non-light water reactor, but they do provide guidance in establishing the principal design criteria for non-light water reactor designs. Regulatory Guide 1.232 provides non-light water reactor design criteria that was developed by the NRC staff and is intended to provide our stakeholders with an insight into the NRC staff's views on how the GDC could be interpreted for non-light water reactor designs. However, the principal design criteria are not final nor binding, and it is the applicant's responsibility to develop them for their facility. There's a table in Reg Guide 1.232, Table 1, that provides a summary and a crosswalk between the general design criteria in Appendix A and the NRC staff determination of how they're applicable to the advanced reactor designs. Our position is that the GDC in Criteria 1 should be used for the principal design criteria 1 as well. In other words, in QA, nothing has changed. The next step in this process is to classify the SSCs that will be used in the facility that will be licensed. Currently, for light water reactors, Revision 6 of Reg Guide 1.26 provides the NRC staff's current guidance on classification of quality groups A, B, C, and D, and provides an acceptable way for the alternative classification for components in light water reactors. Before an applicant or licensee is allowed to also implement 10 CFR 5069, the NRC must approve this risk-informed categorization process. For example, a licensee will submit an application for a license amendment under 10 CFR 59.90. This amendment will contain information required by 10 CFR 5069 Bravo 2. The NRC will review the application and then will issue the license amendment, approving the application if it determines that the categorization process satisfies the requirements from 10 CFR 5069 Charlie. Also, Reg Guide 1.201 provides the staff guidance, interim guidance, for complying with the NRC's requirements in 10 CFR 5069, and it uses the process described in NEI, Nuclear Energy Institute document 0004 to determine the safety significance of SSCs and place them into the appropriate risk-informed safety class categories. The SSCs, the significance of the SSCs is determined using an integrated decision-making process which incorporates both risk and traditional engineering insights. The safety functions of these SSCs include both the design basis functions, which are derived from the safety-related definition, and from the functions credited for preventing or mitigating severe accidents. Treatment of requirements are then commensurately applied to the categorized SSCs to maintain their functionality. Next, we have, which I'm sure a lot of you are familiar with, Revision 1 of NEI 1804, which provides one acceptable method for non-light water reactor designers to use when carrying out, when preparing their applications. The methodology documented in NEI 1804 provides a process by which the content of applications will allow understanding of the system designs and their relationship to safety evaluations for a variety of non-light water reactor designs. The system designs and safety evaluations may also demonstrate compliance with or justify exemptions from NRC regulations. And although the technology-inclusive methodology provides a common approach to selecting licensing basis events, classifying SSCs, and also assessing in-depth defense in-depth, the applicability of specific technical requirements in NRC regulations or the need to define additional requirements arising from the safety evaluations is made on a case-by-case basis for each non-light water reactor design. Reg Guide 1.233, which endorses NEI 1804 as an acceptable method for assessing and classifying non-light water reactor SSCs as either safety-related, non-safety related with special treatment, and non-safety related with no special treatment. It does do this with a few conditions and clarifications. The first clarification is that the classifications and logic outlined in NEI 1804 are part of an integrated methodology which includes a defined relationship among licensing basis events, equipment classification, and assessment of defense in depth. The classifications and related outcomes may not apply for alternative approaches that do not follow the NEI 1804 methodology. The NRC staff expects that SSCs that provide essential support, including those that require human actions for safety-related or non-safety-related with special treatment, will be classified in a manner consistent with the higher level function, even if the SSC is not explicitly modeled in the probabilistic risk assessment. The second clarification from the reg guide is that the classifications outlined in NEI 1804 include the term safety-related, which is defined in the NRC regulations 10 CFR 50.2. The use of the term safety-related in NEI 1804 for non-laboratory reactors is not the same as in the definition from 10 CFR 50.2, and the SSCs included in the safety-related classification for non-laboratory reactors may not be the same as those considered safety-related for light water reactors. Also, the term non-safety-related is used in NEI 1804, but this is not a defined term in NRC regulations, and it has a different meaning depending on the context which is used. As used in Reg Guide 1.233 and in NEI 1804, the term non-safety-related means, no surprise, an SSC that is not safety-related. NEI 1804 does include a glossary that will help alleviate some of the issues that arise from the differences in the definitions and the use of the terminology. Any applicants that is referencing Reg Guide 1.233 and is expected to use the terminology in NEI 1804 and as needed, identify any exemptions from NRC regulations. Not going to spend a lot of time on this slide. This just includes the definition of safety-related from 10 CFR 50.2, which I should mention is not the same as the definition from safety-related in NEI 1804. Excuse me. Here are some of the, well, not some of the 4 risk-informed safety classes from 10 CFR 5069 and the definition of non-safety-related with special treatment from NEI 1804. For risk 1 and 2, the treatment that's applied to these SSCs ensures that it supports the key assumptions in the categorization process that relate to their assumed performance. For risk 3, the treatment of risk 3 SSCs must be consistent with the categorization process, and it also must include inspection and testing and corrective action to make sure that the risk 3 SSCs remain capable of performing their safety-related functions under design basis conditions. So the next step is to apply the appropriate quality controls, and Appendix B to 10 CFR Part 50 has always allowed for a graded approach. The phrase importance to safety is used a total of 13 times in 10 CFR Part 50, and this phrase is typically used within the context of defining important to safety SSCs, which are components that are crucial for ensuring the safe operation of the nuclear power plants. Now, the NRC does define this term broadly in the introduction to Appendix A to 10 CFR Part 50 as SSCs that provide reasonable assurance that the facility can be operated without undue risk to the health of the public, health and safety of the public. And I believe most of you are familiar with these documents. These are the documents that contain the NRC's guidance for implementing QA programs that meet the requirements of Appendix B to 10 CFR Part 50. We have Chapter 17.5 of the Standard Review Plan, which provides guidance on developing quality assurance program descriptions for design certifications, early site permits, and new license applicants. We have Reg Guide 1.28 for design and construction, which endorses NQA1 as one way of meeting the requirements of Appendix B with conditions. And we also have Reg Guide 1.33 for operations, which endorses the ANSI ANS standard for the operational phase of nuclear power plants with conditions as well. So just a few reminders to wrap this up. There are also state and jurisdictional requirements for some of the ASME code components when it comes to quality. Any applicant should be aware of these requirements for the location of their facility, and be aware that sometimes these requirements from the state and jurisdictional entities are even more limiting than the federal requirements. And I didn't put it here, but you can't forget about NUREC 1055, which is titled Improving Quality and the Assurance of Quality in the Design and Construction of Nuclear Power Plants. The report is dated from May 1984, way before my time, which was issued to Congress. And Congress had asked the NRC to document a study of existing alternative programs for improving quality and the assurance of quality in the design and construction of commercial power plants. A primary focus of the study was to determine the underlying causes of major quality-related problems in the construction of the power plants. And what the study found, that the root cause of the majority of the related problems was the failure or inability of some utility managements to effectively implement a management system that ensure adequate control over all aspects of the project. And as most of you know, some of these plans were never finished. So now to conclude, I want to go back to a point I made at the beginning of my presentation, and that is that not adequately implementing a nuclear QA program can result in significant cost increases and schedule delays. And with that, that is all I have. Thank you very much for your attention.
Thank you, Yamir. Our third presenter is Ms. Aixa Belin Ojeda. Aixa serves as a senior reactor operations engineer and lead inspector in the NRC's Quality Assurance and Vendor Inspection Branch. Previously, she was the manager of project quality assurance and manager for supplier quality at X Energy, where she was responsible for quality assurance programs and supplier oversight activities. From 2017 through 2021, Aixa served as a senior nuclear safety enforcement specialist at the U.S. Department of Energy, where she led several investigations related to nuclear safety incidents at facilities in DOE's complex. From 2006 to 2017, Aixa held several positions here at the NRC. Welcome back to the fold, Aixa. The floor is yours.
Thank you, Carrie. Good morning, everyone. In this presentation, we already heard our previous presentation where we discussed all Appendix B requirements and how to apply them in a greater approach. But in this presentation, I'm going to expand more into non-safety related special treatment. We are going to touch the classification, what it is, what's the purpose, and guidance documents and takeaways. The purpose for this presentation is discuss the quality assurance requirements for non-safety related special treatment components as classified in the Nuclear Energy Institute 1804 Revision 1, which was endorsed in Reg Guide 1.233, which my colleague Jamir went more into details in there. So as the previous presentation kind of alluded to, the classification of system structures and components in NEI 1804, it is a little bit different from our regulation, but it also is more in risk-informed terms. So we have the safety-related components, which are selected by the designer to perform required safety functions to mitigate design basis events and design basics accidents while meeting those limits using conservative assumptions. The non-safety related special treatment, we'll go more into detail in the next slide, and we have the non-safety related with no special treatment which perform non-safety significant functions. I want to emphasize that safety significant components include the safety related and the non-safety related special treatment. The document NEI 1804, this is a diagram, but they do have a acceptable way of classifying these components to go more into detail related to the risk-informed classifications. So what are non-safety related special treatments components? These non-safety related special treatment components perform risk-significant functions or are necessary to maintain the defense in-depth adequacy. These functions prevent or mitigate events so that the licensing basis event do not exceed frequent consequences targets. While non-safety related special treatments are not safety related, they are indeed included in the reliability assurance program to ensure their reliability and capability align with the plan's safety and performance requirements throughout the operation. So what are the purpose of a special treatment? This reg guide was also mentioned in the previous and went into detail. Regulatory Guide 1.201, guidelines for categorizing structure, system, and components in nuclear power plants according to their safety significance, states that special treatments refers to those requirements that provide increased assurance beyond normal industrial practices that the components perform the design basis functions. These components require case-by-case evaluation to determine the special treatment, focusing on providing adequate assurance of their performance in the prevention and mitigating roles. So what guidance documents for non-safety related special treatment documents the NRC have? We have SRP 17.4, Reliability Assurance Program. This program is provide regional assurance to for the plant that is, to make sure the plant is designed, constructed, and operated in a manner that is consistent with the risk insights. We also have as the SRP 17.4, the Quality Assurance Program, but in specifically the Section 2, subsection U, non-safety related system structures and component quality controls is the one that provides the guidance for these components that are significant contributors to plant safety. As a side note, this is the document our group uses to review the quality assurance program document submitted to the NRC with each application. While non-safety related special treatment components are not required to meet the same rigorous standards as the safety related components, quality assurance and quality control processes are still required to ensure that failures of these components do not lead to significant plant operational and safety issues. Special treatments are mostly tailored to the component-specific safety and risk significant roles and functions, so it is specific to the component function. Special treatments oversight may change depending on the project phase application and the licensees. If you are in a design certification application, you will definitely focus more on the design aspects of those components. If you are in the construction permit or a COL, you will definitely pay more attention to procurement and manufacturing and inspection and construction of these components. Operations will be more focused on operational testing, maintenance, and technical specifications. For additional information, NEI 1804, Table 5.7 kind of provide examples of special treatments considered for programmatic defense in depth. So to determine the quality assurance programmatic controls, this can be accomplished in so many ways. This can be accomplished by doing an Appendix B integrated approach or have a separate QA program for those specific components. But most of the areas that are focused on this programmatic controls is the organization responsibilities. Who is responsible for this component in the safety function? Design control, including configuration control of this component. If you wanted to act when it has to. Independent reviews of the design, what kind of software you use, and the verification and validation of that software used for design. Procurement documents, what kind of technical requirements and quality assurance requirement you're going to put in your contract with your suppliers. What kind of procedures and instructions you're going to follow. Inspection, surveillance, source verification of the components, and any audit necessary for that supplier. And of course, we usually have a corrective action to correct everything that we have and the records. But why does it matter? Why does QA matter for non-safety related special treatments? So it's the life cycle assurance. We want to employ preventive measures to ensure the functional and performance reliability throughout the plant's operational life. We don't want it to fail. We want to support event mitigation and adherence to plant safety goals. And also, it is part of our regulation, and it needs to meet NRC expectation for defense in depth and perform base evaluation. So what are the takeaways of non-safety related special treatments? These components are important to the defense in depth and risk management. Their quality requirements ensure performance, reliability tailored to their safety and risk significance. And a systematic approach to deal with these components strengthens the plant's safety and the regulatory compliance. So I thank you. I'm really looking forward to the discussion and the questions and answers.
Good morning, and thank you to Carrie for asking me to be here. I am Tanya Sandquist. Oh, you wanted to introduce me
I was
first.
going to introduce
Go right
you.
ahead. I can make it a lot shorter, but go right ahead.
Oh, let me go ahead. You prepared it, so let me do that for you.
Okay, so
Okay, so thank you, Aixa. Tanya's very excited about being here. Our fourth, and not our least presenter, is Ms. Tanya Sandquist. Tanya has built a distinguished career spanning over 35 years across diverse fields, including engineering, safeguards and security, environmental management, construction, and as a quality assurance expert. On the international stage, she represents the United States on IAEA Task Group for Codes and Standards, design, engineering, testing, and manufacturing components of small modular reactors. She serves on the ASME Board of Nuclear Codes and Standards and is currently the chair of the NQA-1 committee. During her career, Tanya has worked and managed people and projects at numerous nuclear and chemical operating facilities and DOE laboratories. For the last 30 years, she has worked at Los Alamos National Laboratory. Tanya, please proceed.
thank you. Yes, I am very excited to be here. I wanted to bring up, although I am the NQA chair currently, I want to say officially that I do not speak for the committee. Obviously, the committee, you would have to submit something in writing, we would vote, and we would put it out there, but wanted to give you some insights. All right, so I wanted to bring up what is going on with the committee with regards to SMRs and those sorts of things. Basically, the committee has been listening. We've brought people in to speak and tell us of your problems. We're looking for people within the SMR industry to be part of the committee. I want to talk a little bit about what the NQA committee is and that what we're doing to address the current challenges and to be part of the solution in this nuclear renaissance. And also we'll bring up how to get involved. All right, so we are listening. I don't know if you've seen some of these questions during some of these meetings. I've heard, well, and then there's NQA-1, and you know, if engineering gets a calculation wrong, it's QA's fault, and if the equipment's too expensive, it's NQA-1's fault, and if a design review takes too long, it's NQA-1's fault. And so I want to talk through some of those. And we've really tried to listen and really hear what's going on. And some of the things we can address, and some of the things, the information that's out there is actually wrong, but people think it's right, and so we wanted to address those also. All right, so before I go too much further, I want to just talk about what NQA is. So NQA is a committee of about 200 volunteers. And we represent 12 countries, over 50 companies, and it boils down to about 30 to 40 members that are the final say with regards to what goes into the standard. And we have to vote. It's a consensus process. We have to keep a balance of interest so that no one industry can get too much of a say, right? So it's balanced. We have to work, a standard development organization, all of our meetings are open to the public, and we have to report to a board that makes sure we stay within the ANSI accredited process of doing a standard. So I wanted, if I could wave my magic wand, all right, I would replace the words quality assurance with a disciplined engineering method when you have to be right, right? There are times, I'm an engineer, I go and I wing it. There are other times when other people's lives depend on it, and I have to sit back and do it very disciplined because I cannot have it wrong, all right? I joke that I apply NQA1 every day, from shopping to helping my grandkids with their homework, those sorts of things. But you do, just by nature, do scientific, disciplined methods based on risk. You just do it as humans. The intent of NQA1 is to prevent errors, right? It is to, and then to mitigate when there are problems. We look at training. What problem are you trying to solve? How can you repetitively do the same activity to ensure it's right? Who's going to check your work? How are you going to buy it to make sure it's right? Once it gets here, how do you know it's not going to get messed with between when it's stored and when it's put in? When you start startup, how do you know which piece of equipment has been started up and tested and which ones haven't? NQA1 is meant to be that systematic process to walk you through making sure it is going to work. And that's part of the problem. If you start too late, you could have made errors at the very beginning that have just propagated their way all the way through the design. So that's the intent. All right, and also NQA deals with when bad things do happen. How do you not just throw your hands in the air? How do you address those issues to maintain control and to get back on course? All right. So we listened to the public. We were part of the ARCSIS. We invite experts from the SMR and advanced reactor industry. And we've come down to about 4 items. One is we admit that the standard can be difficult to read, all right? We find that many people have actually not read the standard, but what they do is they quote what somebody else said that the standard says, all right? We actually swapped horror stories on what we had heard during NQA training available on YouTube or just pick somewhere, that it's somebody's opinion of what the standard says. And with that, we came up with 3 initiatives that the NQA committee is working right now. And they are to clarify, to clean up, and to create. And I'll go through each one of them. And I think that there was an individual yesterday who talked about this in being clear in what the standard says. So one of our first initiatives, and I'm assuming you're all experts in NQA, right? You look at the book, and I will tell you that the requirements are probably within 20 pages of that book, all right? It is not the entire book. That is where the requirements are. You can certainly read it. We are going through an initiative to take Part 1, which are the 18 requirements, Appendix B driven, and put them into clear language so that there are requirements in equal requirements out. We want to make sure that you can clearly understand what's being asked and you understand who's supposed to do what. Before I go to the next slide, I just wanted to tell you where this started from. I don't know, about 5 years ago, Tom Pastor, who's the Senior Vice President for Codes and Standards, put up a section of his code, and I've been an engineer for 30 years, and he put up a section of it, and I thought to myself, I have absolutely no idea what that says. And he went through the protocol about talking about clear language, and I said, well, it's a good thing NQA doesn't have that problem. So I opened to a certain page and I looked at the first sentence, and when I go to the next slide, I'd like you to look in the upper left-hand corner and just read the 39-word sentence, if you can. All right, and I can actually read. Activities affecting quality and services shall be prescribed by and performed in accordance with documented instructions, procedures, and drawings that include or reference appropriate quantitative or qualitative acceptance criteria for determining that prescribed activities have been satisfactorily accomplished. So who's supposed to do what, right? What I can say, and actually Aaron Armstrong on the NRC has helped head up this effort with Requirement 5. In the 2026 edition, we are looking and proposing to have the requirement, so we have a 39-word, a 26-word, and a 38-word sentence. We are looking at moving it to what is in the right. The organizations have to have a work control document. You don't just get to make it up as you go. How are you going to consistently do your work? It defines what's good enough. It talks about how do you prove when a certain procedure or instruction procedure is good enough. And it asks that you think of your audience. Who is the least knowledgeable but qualified person who's going to use that document so that you're writing for them? Not the auditor, not the senior one that's been doing it for 30 years. But that is requirement 5. All right? And I have seen some companies implement this requirement with very streamlined procedures that probably have maybe 5 or 6 requirements. I have seen other companies implement this with dozens and dozens of page documents, right? It still gets you to the same place. So in 2026, again, part 1, we will not get the whole document, but we will have done part 1, and we are going for also part 2.7, which is software, and also 214, which is commercial grade dedication, that those sections will all be in clear language. All right, cleanup. We spoke a little bit about this. At some of our NQA1 meetings, we have swapped horror stories of when we have had auditors come in and tell us, oh, you have to do it this way or you have to do it that way, and NQA1 says this or that. And what we found is if you're an engineer, right, you have a professional engineering exam that holds the bar, right? Or a CPA or a doctor, whatever the case is. There is currently no such thing specifically for quality assurance. Anyone can declare themselves a quality assurance expert. So what we're trying to do, and this is the only training we can really get our hands on right now, is the ASME training. The committee has never taken the ASME and QA training. So we're looking at that, trying to make sure it's clear, because usually what happens is an expert or person comes in and gives their version of what they think is important about the standard. I cannot repeat more. Read the standard yourself rather than go off what you think someone else says. So again, we're looking with ASME and thinking, well, maybe we should put exams at the end of these trainings to make sure people are taking away the right information. Also, I kind of hinted to it, we are looking at putting together like an NQA-based knowledge exam, where someone would have a copy of the standard and the exam. And it's not for lead auditor. This would be for engineers, procurement, folks that it would basically force them to go in and look at the standard, see what it says, make sure they understand it correctly. Not that it would be a required exam to do certain things, but it would be a way of providing something on a resume to say, you know what, I know enough about truly the standard to have passed the exam or the badge, whatever it is. And it is certainly not to be a moneymaker, but it is trying to get all the misinformation back in a box. If someone keeps taking it and they can't pass it, chances are they'd probably need to go back and read the standard. Lastly, we've probably been asked, why does an NQA1 allow a graded approach? And I actually went in, and if you look in the definition section in NQA, there is a definition of graded approach. But if you do Control F in the document, you will not find graded approach in 1 through 18. However, the statement in there commensurate with the importance of the item. So to help folks, maybe we need to go and put the exact words in there, and that's something we'll look at it in the 2026 edition. But graded approach, the philosophy for a graded approach has always been in there. There is actually a subpart on graded approach for applying NQA to R&D. There is a section 3.12-5, which is performance-based or risk-informed approach, but it is specific currently to not NRC license applicants at this point. But NQA has always allowed for a graded approach, and when you go through and you read the 18 requirements, you can see where your possibilities in ramping up or ramping down on just how correct you need to be for each application. We're also looking and playing with the idea, coming from a Department of Energy lab, of an NQA 10. And what that would be is incorporating the lessons learned from NQA-1. Also, the Department of Energy works off 10 CFR 830 subpart A, which is based off 10 criteria versus the 18. They match back and forth. But also, where in Department of Energy land, a reactor is a hazard category 1 facility. Well, the Department of Energy also has HAZCAT 2s and 3s and 4s and radiological facilities, so we kind of can grade down. And we're looking at taking and creating a standard that would be able to be applied for those lesser type facilities. Now, again, we only have 33 members, and I'm working them very, very hard on the clear language effort. But this NQA 10 is something that we're looking forward to. Lastly, our ASME Secretary, Abena, is actually here, and if you would like to get involved, I would greatly appreciate if we could have advanced reactor folks come and be part of the committee and to share their experiences where their challenges are. At the last meeting up at Idaho National Laboratory, we had multiple presenters, and we actually had breakfast with NQA. And they came in, and each of them for 10 minutes got up there and said, you know, this is where I'm having a problem. And they literally put the sentence up on the screen, or this is what's costing my company empty squats about money. And within, you know, within the morning, there was much more clarification in the way that they had read it or misread it. And so just bottom line, we look forward and we invite you to participate. And as an NQA committee, we want to see the advanced reactors folks helpful and, again, hopefully get NQA to recognize. I joke that in quality assurance, my job would be to work myself out of a job because it's just the way you do your work as an engineer when you know you have to be right. And with that, I look forward to questions.
Well, thank you. So I would like to thank all of my presenters for your time and the energy you put into your presentation. So we're gonna open it up now to questions. The first question is for Brandon. What would you say is the biggest difference between Canada and the U.S. quality assurance and vendor oversight?
All right. So if you ask different QA people, I imagine you probably get different opinions on this question, but it's directed at me, so I'll say what I think my choice would be. The oversight of the regulator and the fact that the CNSC doesn't do direct inspections of manufacturers is probably the biggest. And the way in which that works for the CNSC is that we will conduct compliance activities and inspections of the licensed facility, of the nuclear power plant, as they conduct the oversight of the suppliers to make sure we're basically verifying their programs in controlling their suppliers for those items. Whereas I know that the vendor inspection branch conducts direct activities, so that's probably my answer for that question.
But you do get the opportunity to go out with your licensees.
And,
right?
and that is one of the ways in which we perform those compliance activities is that a licensee will be going on site as part of their pre-delivery inspection of a component or an ITP as part of the manufacturing process, and will be invited to accompany them along and basically watch what they're doing as they conduct their oversight activities. And then our feedback or our inspection report relates to the level of robustness of their program and whether or not they're meeting their requirements as written for that activity.
So the Canadian approach is very similar to a lot of the international community, where the regulators will go out and accompany the licensees to the licensees' supply chain on their audits. France is very similar to the U.S., but they do hire a third party to do supplement their inspections. So they not only, ASN is the French regulator, I think they just merged, but they typically will inspect their supply chain, and they'll also inspect the third party provider to make sure that they're properly providing the adequate oversight. Anything else?
In a similar way, Canada has a group called CANPAC, which is basically an organization unto itself that is hired by the nuclear power plants to conduct inspections and audits of suppliers. And the benefit that they get out of that, the various power plant facilities, is that one group goes to do an inspection of a manufacturing facility or a company, and that report then can be used by all of the licensed facilities that use that same manufacturer. So it helps to avoid duplication of effort.
Right. That's very similar to NUPIC
Yes,
in the US.
yes, they are, yes. And the CNSC does participate and join in on meetings. We don't conduct the inspection activities with CANPAC, but we do go to routine meetings where issues get discussed, just so that we're abreast of what's going on. And in a similar way, we are often invited to NUPIC meetings as well, to be aware of the same kind of issues that are occurring in the U.S.
Right, and so most recently, NUPIC had conducted an audit in BWXT in Cambridge, and so the NRC decided to observe that audit, and that offer to observe the audit was also offered to CNSC, which you also sent a representative. So both countries got to see the U.S. doing their audit and how they responded to the licensees. So that was good.
Yeah.
All right. The next question is for the NRC staff. Can you discuss the thoughts from the international community on vendor oversight now that the world has moved into a global community economy? You want to start? Aixa? Yeah. If not, I can take it.
How they move to global.
Yeah. So the question is, can you discuss the thoughts on from the international community on the vendor oversight now that the world has moved to a global economy? No? Okay, I'll take it then. Sorry, I'm putting my staff on the spot. So I was hoping that you would have experience from your previous occupation, but you want to try that one?
In that aspect, yes, I thought for NRC purposes.
Yeah.
The supply chain has totally increased. There's a movement by the DOE to try to find suppliers, American suppliers, U.S. suppliers, but there's been a lapse from the last time the United States have constructions of nuclear power plants in the United States. So those kind of suppliers will have to kind of start all over. So there's a lot of movement with international suppliers and how to incorporate international suppliers in the inside U.S. Supply chain for new nuclear reactors. It is a very different with perspective for NRC with respect of how we do the oversight for those international suppliers, which Carrie can go more into details. But there's a lot of conversation, from my understanding, among all the regulators of how to maintain oversight of the supplier and how to share information with those respective suppliers. I've seen a different kind of quality assurance requirements for different suppliers and how they merge different quality assurance requirements to meet different regulatory quality assurance requirements. I had the opportunity to inspect Appendix B QA programs, but at the same time CSA QA programs and how they merged that and what's the different in those aspects. But you can explain.
Okay, yeah, so from on an international viewpoint, There was a group stood up, which was called the Vendor Inspection Cooperative Working Group back in 2008 under MDEP, which is the Multinational Design Evaluation Program. That group was focused on the supply chain of the new reactors, the large lights that were being built at the time. There was about 6 member countries, and we set up a program to do joint and multinational vendor inspections. That organization conducted 4 multinational inspections. They were big teams, having 9 different regulators work under the host country's regulations. We figured out a process. That organization has since moved to the CNRA, the Committee on Nuclear Regular or something. I can never get it. It's out of the NEA in Paris. But it's now called the Working Group on Supply Chain. That group has expanded to at least 13 more countries have been added. And the goal is to continue to share inspection results. The goal is to observe each other's inspections when they align to the same supplier to the different countries. And the hope is to take credit for those different inspection activities by other countries as our resources as regulators continues to dwindle. So that's the main goal of the committee is to get some assurances about the processes from other regulators to make sure that we can credit those activities in our own framework, such that it's one less activity that the U.S. regulator may have to perform. So that group meets twice a year. That's another meeting coming up in May. It's getting a lot of exposure internationally. So it's a really good program, at least for the regulators, as they continue to build on the experience of all the joint and multinational inspections that they were able to conduct. Next question is also for the staff. Is there an industry precedence for accepting alternative to NQA quality programs for nuclear power reactor applications?
Can you repeat the question, please?
Yes. No. Where did it go? Okay. So no. Is there? Can you provide as a reactor applicant provided another program outside of NQA-1 to meet Appendix B?
Certainly. I mean,
Is there-
NQA-1 is
there precedence for it?
or precedent for it. Not to my knowledge.
Oh, I would change that answer. Try again.
Okay. Then yes.
Well, most.
Phone a friend.
Well, yeah, most of our reactors were built on the predecessor to NQA-1, which is the N45 series. So technically, yes, NQA-1 was not in existence when our first operating fleet was built. So you could. Did you want to talk about other alternatives within NQA-1 that might help? It's not a full-fledged replacement of NQA-1. The staff approving alternatives to NQA-1? IEX is going to help you out.
Okay.
That all depends of the application that the applicant is sending. It has to provide the background for those kind of exceptions. And as a team, we will review that. We will determine if it's compliance with Appendix B and our regulations, and we can definitely approve those through a safety evaluation of their quality assurance program description.
Right. Most applications that we see are not 100% NQA-1. There's always clarification and alternatives that we've approved throughout the last 40, 50 years. So we have to look at how those alternatives were approved. Is the basis still applicable? So it's not a 100% NQA-1 program. The requirement in the regulations is they have to tell us how they're going to do it. It doesn't dictate which program, NQA-1, you're going to use. So it's a combination. All right, good? Okay. Next question's for Aixa. Do you have to use NEI 1804 to use NSRST classifications for SSCs?
No. As Jamir explained in his presentation, there's other ways of classifying system structures and components and how you want to define them. Again, it's the same the licensing process of how you want to do it. The NEI 1804 is just one endorsed process of how to do that specific classifications, and we have endorsed that. But any applicant can come up with how they want to classify it and either follow the reg guides. There's different reg guides about classifying components. It is up to the applicant to decide which one you want to use and how you explain it in your application for the NRC to review and approve. Obviously, as I mentioned before, it has to be well explained why you choose that and back up with enough information for us to make that determination.
Okay, thank you. Aixa, the next question is for you, and it's a long one. You ready? Special treatments are selected on a case-by-case basis. In this case, it seems inappropriate to wholesale apply the QA relaxation specified in Section U of New Reg 0800, Chapter 17.5, which is the staff's guidance on doing reviews of QA programs. We are planning to capture all special treatment requirements in DRAP, the Design Reliability Assurance Program. Thoughts?
It is a requirement under 17.5 to kind of capture all those requirements. You either have it in our quality assurance program description of how you explain it, or you can inform us that it's included in the 17.5 reliability assurance program, and then we will kind of work with our team that is responsible for that standard review plan, and we will review it in that aspect. But it doesn't have to be 17.5. It has to cover the special treatments that you're going to use and how you're going to control those to provide reasonable assurance that those specific safety significant components are going to work and provide the safety function. But either you can do it in one way or you can do it in another, as long as NRC have the opportunity to review and you have enough information to prove that.
All right, thank you. Tanya, the next one is for you. Discussion of simplifying NQA1 was one of the topics you brushed on in your presentation. Has the board considered having a non-industry member, such as someone with a background in English language grammar, to review the revisions to determine clarity of changes from a perspective that has little to no nuclear background?
Great question. I wanted to clarify. So we are not simplifying NQA1. We are making it clear. I wanted to make that clear, that it's requirements in to requirements out. So clarity is the key, and during these evaluations, we're actually having members of NRC and Department of Energy and all that to look at one side, the before and the after. The requirement is the same. It is just more clear. And certainly, we are having a variety. We have English as a second language individuals. You know, the question is how. Who is the intended audience? We have technical editors from ASME going through it, looking to make sure. One of the things that I've done with a couple of my sections is put together like a little quiz, right? And I give them the before and see if they can answer those questions. And then I give them the after and see if they can answer those questions separated by a week. Because the intent is that when they read it, they should be able to answer 100% of the questions and get them right. And again, we do have people that do not have English as their first language. Are we going to get this perfectly right in 2026? Probably not. I think this will be another effort, but hopefully a step in the right direction. I would hope that in 2028, the entire document that would be that way. But at least the requirements in the 18, 2.7, and 214 software and commercial grade dedication should all be clear, not simplified, but you'd look at it and go, oh, I can do that, right? And that's the intent. I think I answered the question. Okay.
Yep, thank you. Ymir, I'm going to give this one to you. Our organization is working to become an ASME MO certified to cast steel products. How involved in NQA1 should we be as we progress in this process?
What was that question?
So,
Steel?
yeah, they're working on becoming an MO for ASME.
MO.
MO.
Oh, okay.
And they're going to cast steel products. So how involved in NQA1 should they be as they're working to get their MO?
Well, I would think that they probably want to be involved also in ASME as well, in Section 3 as well. But given that, NCA Section 3 requirements refer back to NQA1 for the equality program, I would think that they will want to have some sort of involvement to ensure that they do understand the requirements from NQA1. If they want to, influence possible changes or interpretations to NQA1, that they want to be involved and possibly just answer Tanya's request for becoming involved in the NQA1 committees and information.
Okay, thank you. So the next one is for the staff, and I'm not quite sure I completely follow, but what thought is being given to how you move from the initial QA to requirements for periodic inspections and potentially online monitoring? So I guess I'm struggling with, are we talking about resident inspector QA questions? Are we talking about an applicant's QA requirements, online monitoring? We're looking at that for operating fleet for some of the tech specs. I'm not exactly sure how to answer this question. If you want to write in again, I will try again. Brandon, next question is for you. Can you explain the review performed as part of the vendor design review process?
Okay. Yep. So, I mean, the easy answer is I can't do it as well as going to the CNSC's website and looking up the section on vendor design review. The vendor design review process is a service that we offer where potential technology designers can come to us, and we perform an extensive review to ensure that there aren't any large barriers to future licensing activities. There's a specific section, it's got a whole bunch of different parts and sections of the review, a lot of technical topics, but part 17 of the review focuses on quality for design. So that's the area where my group gets most heavily involved. There is a specific reg doc on design requirements, reg doc 2.5.2, and there is a section on the quality requirements for that. So it's not a full inspection or audit of a management system for a company that's looking to develop a technology that may eventually get licensed in Canada, but it does focus on the key aspects that are requirements in Reg Doc 2.5.2 around quality of design. And so our group gets sent a lot of the documentation to look at well in advance that we would otherwise have to look at as part of an application process, and we go through it and compare it against those requirements for the design. It involves usually a set of meetings like an inspection of about a week for us to ask clarifying questions and to have discussions around making sure we know what we're looking at, what we think we've seen. And then there are reports that get written for each section, and eventually a fulsome report that talks about any gaps, like I said, any potential barriers to licensing, which includes all of the technical reviews on the different parts as well as the quality assurance component that we are heavily involved in.
Great. Thank you.
Yeah.
Tanya, next one is for you. Can you elaborate on why NQA1 ASME certification does not alleviate audit oversight requirements?
Say that one more time.
Sure. Can you elaborate on why NQA1 ASME certification does not alleviate audit or oversight requirements?
So regulators can always do what they want, right? I was going to say, and an ASME and NQA1 certification, I think currently there's only maybe one or two. And just think of it, just because you got through that certification once, right? Does that mean that in 5 years, 10 years, whatever the case, it should provide some reasonable assurance that those programs and processes are set up, but everything is performance-based, right? You know, you can't take a snapshot in time and think that it's going to go on forever. And also, an ASME certification is not the same as the regulators coming in and taking a look at it. I'm not sure if I'm the right person to.
To answer the question.
Yeah.
Yeah, I mean, the NRC requirements, Aixa, did you want to talk? Go ahead. I'm sorry.
So NRC requirements for audits kind of requires Appendix B and 10 CFR Part 21. And even though a supplier can have a certification for NQA1, that doesn't kind of give us a the reasonable assurance that they indeed implement that program adequately. So, and they indeed have a Part 21 program that will include for safety related. So as Tanya mentioned, yes, you in the certification, you provide everything to kind of like, yes, I have the program, but is, as she mentioned too, is performance-based. We want to know that the way they're implementing the program is adequately and is not really affecting the safety-related function of the components.
Yeah, I just wanted to say, like, Appendix B requires oversight criterion 7, and same as, you know, ASME has, you know, the certificate holders that have ASME certificates, either N stamps or MPT stamps. Material suppliers may have a quality system certificate, but that doesn't relieve them from a requirement from Appendix B to providing the triennial audit or audit of those suppliers. So the certificate holders and those certificates are not a substitution for not having to provide oversight of those suppliers.
Okay, thanks, Shamir and Aixa. The next question is to the staff, and I'm just going to take it. It says, are there any recommendations for an existing nuclear plant looking to convert to NQA1? Several utilities did this back in 06 through 2010. NEI has guidance on it that we endorse. It's NEI 0614. Revision 9 is probably the one you want to look at. It has an appendix to it that helps the existing utility do a comparison of what is in their QA program to what they're going to. It's going to be what the staff is going to need to see in the conversion to NQA1. It's unlikely that because of it not being the existing QA program for an existing plant is not strictly going from one program to another. They've had alternatives through the years, so it's likely that the review from the NRC is going to have to be done under 5054A4, because there'll probably be a few reductions in commitments, but it's something that the utility would need to determine as they're doing their review. So that was NEI 0614. Yamir, next question's for you. When reviewing a QA program for an applicant, do you perform QA audits to verify compliance?
We're almost out of time, just kidding. What was the question again, I'm sorry?
When reviewing a QA program for an applicant, do you perform QA audits to verify compliance?
We may.
Okay, let's be a little bit clear. Where is it laid out, and where does the QA program that you're inspecting? So, can you help them out? Am I helping you any? If they submit it under a topical report, do we do inspections for compliance then? Straight topical report?
Straight topical report?
Yep.
No.
Okay.
No.
If they are an applicant for CP, OL, DC, blah, 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 would we do an inspection then?
Yes.
Under what manual chapter?
Right.
Hey. So it's not meant to be a board. We have inspection manual chapters that define when we're going to do inspections of applicants, but it's usually we have to wait until there is an application, not just a topical report. Sorry, Yamir, I apologize.
It's okay.
Oh, my goodness. I'm going to give you the next one then. You ready?
Sure.
Okay. I think this alternative to NQA1 question could rise to the forefront in the context of nuclear graphite, which is a material for many advanced reactor concepts. For graphite, the kind of raw material uniformity in force for metals is difficult or impossible. Do the panel members have any thoughts they'd like to share on alternative to NQA1 specific to nuclear graphite? Are the panel members aware of any analogous problems in the industry has faced in the past?
That's a mouthful. I would say that, currently we did endorse, we're in the process of endorsing revision 3 of HSB, processing the issuing revision 3 of Reg. 1.87 for the endorsement of Division 5 of ASME, which deals with graphite materials. But I would say that, right now, I don't see any difference from how we treat graphite in terms of QA requirements. We are, like I said, endorsing Division 5. Division 5 does references back to NCA requirements, and even HSB, which is dealing with graphite materials, has their own standalone QA program, but it's also based on the requirements of NQA1. So right now, there is no difference, I would say, with how we treat QA requirements for graphite.
Right, and it sounds like the question's more of a material, technical question than a quality question. Brandon, did you have anything you wanted to add?
No.
Okay, all right. You just looked excited. Well, this next question's for you.
I'll try and give some context.
Okay, does the Canadian regulatory authority endorse a specific QA program standard for its licensees? Do you endorse or accept alternative to NQA1 QA programs such as ISO 9001?
All right. So in Canada, the regulations state that an applicant for a license to construct or operate a nuclear power plant, for example, must define their management system. And generally speaking, those applications demonstrate that the applicant meets the CSA standard N286-12, which integrates requirements for quality, environmental management systems. It endorses integrating all of those programs into one management system for the applicant. what we have seen traditionally is that the applicants then have to define their QA programs for supply chain, for procurement, and what we have received from those applicants are programs that refer back to the CSA N299 standard that I talked about in my presentation. That's an approach that we have been able to verify that works. The N286 standard is deliberately doesn't say you have to use this QA standard. And so in the application, in the information that is supplied to the regulator as part of trying to get a license, you have to define what the quality assurance programs are, and we leave that up to the applicant to tell us. At this point, we haven't had an applicant come to us with only ISO 9001. Although I note that ISO 9001 is, the newest edition is much more a management system standard than a quality assurance standard anyway, so I'm not sure it would apply. It's not, some of these other standards are manufacturing quality assurance standards, whereas ISO 9001 can be applied way more broadly.
In fact, it's at the car dealership down the road. They're ISO standard certified. All right, so we've run out of time. We're pretty darn close. We're over time. I apologize for running over time. I want to thank again my panel members for providing very detailed presentations, and I want to thank everybody that took the time to come and ask questions and learned about a little bit more about QA and how to apply it going forward. Especially those hopefully online listening too. So with that, I need to close the session. Thank you very much.